Okay, for question 5, air is flowing through a ventimeter whose diameter is 6.6 at the entrance, location 1, and 4.6 at the throat, location 2. Okay, shown in figure 3. The gauge pressure is measured to be 84 kPa at the entrance and 81 at the throat. Neglecting frictional effect, show that the volume flow rate can be expressed as this and determine the flow rate of the air. Take the air density to be 1.2 kilogram over meter cube. Okay, so to show the first one, so we take point 1 as the main flow and point 2 at the throat. Okay, point 1 at the so this is 2, this is 1 here. Okay, since Z1 is also, from here we see Z1 is equals to Z2, we take at the middle. Okay, and then apply to the Bernoulli equation. P1 square over rho G plus V1 square over 2G plus Z1 is equals to P2 over rho G plus V2 square over 2G plus Z2. Okay, and then so this one cancel out. And we rearrange and we get P1 minus P2 is equals to rho V2 square minus V1 square over 2. Okay, so this is equation 1. Okay, so because we want to show the this is V dot, okay, so that is the mass flow rate. So we use the conservation of mass equation. So okay, flow rate at 1 is equals to flow rate at 2. Okay, and so from here flow rate is A1 times V1 equals to A2 times V2. So we get V1 is equals to, okay, equals to Q. So that's the flow rate is same, constant. So this is equals to Q over A1 and V2 is equals to Q over A2. So here we got the Q. Okay, Q is equals to, Q is another way to write V dot lah, the mass flow rate. Okay, so we substitute these two, okay, into here. Substitute into equation 1. We get P1 minus P2 is equals to rho, okay, V dot over A2. So this is V2 square minus, okay, V dot over A1 square divided by 2. And when you simplify, okay, you will get this is equals to rho V dot square, this is the flow rate, over 2A2 square times 1 minus A2 square over A1 square. Okay, and rearrange, we got, okay, V dot is equals to A2 over times with square root of 2 P1 minus P2 over rho 1 minus A2 over A1 square. So here shown. Okay, and then it asks you to determine the flow rate of the air. So to determine the flow rate, okay, just substitute the values in this equation, this given equation. So the flow rate V1 is equals to, okay, A2 is pi, okay, it's a circle, so pi d square over 4, that's A2, times with 2 B1 minus B2 over rho 1 minus D2 over D1 power 4. Okay, so this is equals to pi times 0.046 meter square over 4 times with 284 minus 81 kPa divided by 1.2 kilogram meter cube times with 1 minus 4.6 over 6.6 power 4. Okay, and then times, okay, and then to change the unit, 1000 Newton over meter square over 1 kPa. Change kPa to Newton and meter, and then, okay, 1 kilogram dot square over 1 Newton. So the answer, you will get 0.134 meter cube per second.